Hello and welcome to Mr. Linford's math course. In this presentation, we're going to continue our talk about the applications of percentages, but this time talk about a specific application, that of simple interest. In particular, we're going to define simple interest and derive the formula for it, and then work through some example practice problems. First, we should identify what simple interest means. Now, before we get into that, I think it's probably helpful for us to really get a concept of interest. And we're talking about interest in terms of financial interest, like banking. Interest is an amount of money you accumulate when you leave money in an account. It's money that's accumulated over time, whether this is money you gave to someone for a loan, whether it's money you put into an account. For example, if you have a bank account, if you have a savings account, let's say, that savings account, for the longer you leave your money in there, you will continue to earn a little bit back, okay? Banks give different interest rates for different types of accounts. So if you give your money to a bank, they will add a small amount of interest to it for the amount of time that you leave your money in that bank, okay? So the trick is, how can you get the most amount of interest rate possible? So that's the idea of interest. When we talk about simple interest, because there's different types of interest, there's different concepts of interest, we're going to talk about simple interest. It's a very standard way of thinking about this. Simple interest is a constant amount of interest earned annually, which is based on your initial investment. Okay, a couple things right there. First off, simple interest is a constant amount. That means you earn the same amount of money every year, okay? Because we're working annually here. So this interest occurs every single year. There are other types of interests out there, okay? There's something called compounded interest. There's where you can earn interest every month in a bank account, every 2 months, 4 times a year. You can earn interest maybe every day or every second. You can break this down in multiple ways. For our case, simple interest, it's very, well, like the name says, simple. We are only earning our interest once a year. So the bank is only going and giving us that money one time a year. And it's the same amount of money every single year, okay? However much you first put into your bank account, that's how much the bank is going to give you an interest every single year, okay? Let's try to think about this with an example. I think that would be probably a bit helpful. Let's say you invest $100 into a savings account. And let's say that this bank gives you an interest rate of, oh gosh, let's go with 6%. That means that your bank will give you 6% of however much you initially invest into the account. And they're going to give that to you every single year. So for the first year, I guess we could call that year 0, the time you first put money in the bank. Your account has $100. Now let's go with year 1. You have now left your money in the bank for 1 year. You still have your $100. Let's say you haven't withdrawn anything and you haven't added anything to it. You still have your $100 in the bank. So our total here is $100. And maybe I should label this total. So first year, you just put in $100. The following year, it's been in there for a year. You still have your $100. You haven't lost that. But the bank has also added 6% of your initial, oh, I'm running out of room. You know what's another word for initial investment? Principal. there's a keyword for us, principal. So let me write that up here. That's how much money you put in the bank to begin with. Okay, so you go and open a savings account. In our case, the principal would be $100 here. That's how much you put in initially. Okay, so that's a shorter word that I can use here. So, year 0, you put in $100. Year 1, you have $100 plus 6% of what you initially put in. Well, what is 6% of what we initially put in? Well, we initially put in $100, so the question now is, what is 6% of $100? Go ahead and pause the video and see what you come up with. Well, hopefully you're saying to yourself that if we need to figure out what the percentage is, this is just a multiplication problem. Let's take 6%, which is a decimal, and we're going to multiply that by 100. 6% of 100 is just 6, so $6. So we could say that you've earned 6% or you've earned $6. So after the first year, when you actually have earned interest, you now have $106 in your bank account. And that's just from leaving your money in the bank. Okay, that's all that it is. You just left your money in the bank. You haven't added anything to it or withdrawn. You put it $100 in there, and the bank says, okay, as long as you have an account with us, we will give you $6 every single year. Okay, so let's go to year 2. So you now have $106. You left that in for all year, haven't touched anything. The bank is now going to give you another $6. And I'm saying you haven't touched anything because we're not going to consider like what happens if you added money to your account or you like deposited or if you withdrew anything, because that would just make it kind of more confusing. But no matter what you did, the bank agrees to give you $6 every year. So now it's $106 plus $6 gets you $112. And then the following year, you have the $112 still, plus 6 to get you $118. And so on and so forth. This is simple interest, okay? This is only happening annually. You're only given this interest annually. And you'll notice that this interest is the same every year, okay? It's a constant amount. It's the same $6 you get every single year, okay? Because it's based on how much you initially put into the bank. So you have to figure out what your interest amount is right from the get-go. So this is not the same as other concepts of interest that you might have. Other people might say, because banks do oftentimes work where they compound interest, they might say that they would find 6% of $106 and then add that on and then take 6% of that higher amount, et cetera, et cetera. That's not this case. That's not simple interest. Simple interest is the same amount every single year. Okay, it's constant. So it would make sense for you to invest a much larger amount every single year. Or I'm sorry, at the beginning of when you open the account, it would make sense for you to invest a very large principal amount to get you a higher amount in interest, right? So, because if I invested, let's say that my principal, instead of $100, let's say that principal I invested was $2,000. So instead of putting $100 into the bank, let's say I put $2,000, and we'll keep the same percentage at 6%. That means that every single year, I will get 6% of 2,000. So what is that? Let's see, 0.06 times $2,000. That should get me 0.6 times 2,000, about 120. So it should be $120 in interest every single year. So this is why it's making sense that we should really, to get much more money from interest, we want to have a larger amount that we first initially put in. We want a larger principal amount. Quick side note. Would a bank ever give you 6% for like a savings account? Would you ever see a percentage like that? No, that is a ridiculously high number. You would more likely see an interest rate of 0.06%. And that's a percentage. If you want to convert that to a decimal, you'd have to you'd have to write 0.0006. So that's why 1% is a good amount, or a little bit above that for an interest rate. So keep that in mind as we work through these problems that have nicer numbers to deal with. So first up, let's try to go ahead and derive the formula for what's going on here. We want a formula that helps us figure out how much we earn in interest over time, okay? So first thing we should do is identify what are the things that are impacting how much money we've earned, okay? In this previous example we just worked on, what's affecting the amount of money we're getting? And what's affecting the interest that we get? Let's start with interest. So interest, we're going to label this I. What affects how much we get in interest? We got $6 every single year as our interest amount. What affected that? Where did this $6 come from? Well, it came from here. We took how much we initially invested, and we took what the percentage was. So we said the $100, we call that the principal amount. This percentage, we're going to call that the rate. So let's define a couple terms before we actually get the formula down. Let's say P here is the principal, which is the initial amount invested. And then we also said the rate. So I'm going to use the symbol R for rate, or the interest rate. This is the percentage of interest earned on the principal. There we go. So, what affected interest? Well, it was dependent on the principal and the rate. That told us how much we got as our interest amount. So we can say here, interest is equal to principal times the rate. How much money we initially put in times what percentage of that money you're getting back. Okay, so that's how you can figure out how much you're getting every single year. So I'm going to write in parentheses here, this interest is the amount per year. So here's one formula for us. Here's how we found the actual interest amount. But let's say we leave our money in there over time, okay? Let's take a look at this previous example where we put in $100 at 6%. So here we put in principal being $100, and the rate is 6%. So we could figure out, we can multiply these together, and we can figure out that every year we get $6 in interest. But what if I wanted to figure out how much money I would have, how much money I would have made in interest over the course of several years, let's say 17, okay? Let's say I opened a bank account and I put in $100 to begin with, and the rate was 6%. So the bank says for every year, we're going to give you $6. That's your interest amount. But let's say now it's been 17 years. So I'm going to say, because remember, the bank gives me this money once a year, only one time a year for simple interest. So let's say it's been 17 years. How much money have I earned in interest from leaving this in the bank for 17 years? Okay? Think about it. I get $6 every year and it's been 17 years. How much interest have I earned? Pause the video, take a quick minute to figure it out, and we'll come right back. Hopefully this isn't too difficult of a problem for you. Really what it's saying is you get $6 per year, so $6 for every 1 year, and it's been 17 years, so you end up with 6 times 17. All right, 6 times 17 should get us 102. Oops. $102. So $102 is how much money you have earned in interest over the course of 17 years. Keep in mind, that's how much interest you've earned, okay? That's how much over the course of 17 years the bank has given you. That is not how much money is in your account, okay? So how much money would in fact be in your account? And let's again assume you never withdrew anything and you never deposited anything. Over those 17 years, you started with $100, and then every year they gave you another $6. So this is how much in total interest, I'll abbreviate that IN. What about total amount in the bank? How much do you actually have in the bank? You initially invested $100 and they gave you $6 for every year for 17 years. So how much do you have in the bank now? Well, hopefully you're saying, well, it's the $100 I started with plus the $102 I've earned. So the bank has given me $102, so I now have $202. That's how much money would be in my bank account. If I didn't touch the 100 I first put in there, I would end up with $202. So these are the different ways of thinking about simple interest. We first have one formula to figure out what interest is. Let's come up with another formula to find out how much interest would have been earned over the course of many years. In our case, we figured out for 17 years we would have earned $102. What could a formula for that be? What did we do to figure this out? Well, we took the interest amount and we multiplied it by however many years it's been. Because remember, this simple interest works annually. You only get your interest check once a year. So take your interest and multiply it by however many years you've been collecting. Let me get some space here. Let's now say another formula. Interest, and this time I mean the total interest earned over time. So in this case, we're saying, okay, you've left your money in the bank for several years and you want to figure out how much you have now. So we figure out our interest like normal. We multiply the percentage and how much we initially invested, the principal, to get how much we earn every year. Then we're going to times that by however many years it's been. So here's the more general formula for simple interest. It's I equals PRT. The P is principal, the R is the rate, and T is the time in years. That's very important to remember. This is working in years. It's similar to before, except before, this formula was for just 1 year. We figured out how much we were earning. Okay, that was just 1 year. This is for multiple years. So hopefully these two formulas are making sense for how you figure out your interest. But I also want us to have one additional formula, and that's for the total amount of money in the bank. Some of the problems that you'll come across with these simple interest problems, some will ask you how much interest have you earned, and some will ask you what your bank account would then be. What I mean by that is, in this problem, we figured out two things. We first said, how much interest have you earned? That was the $102. I also asked you, what would your bank account then be? That was the $202. Students tend to mix these up. Oftentimes I might say, what would your bank account be after 17 years? So students will figure out what the interest was over a 17-year period, and they'll say, oh, $102. There you go. And I'll say, wait a minute, I put in $100, and after 17 years, it's only at $102? That doesn't make sense. And then they'll say, oh, no, $102 is what you earned in interest. You have to add that to what you still have in the bank account. $102 is what the bank has given you all this time. You still have what you initially put in. So I want a little formula for that as well. Something that says how much total amount of money we would have earned considering how much we initially put in. So let's say a total earnings. Here's a formula for the total earnings, how much money you would have left over. I'm going to say A for annual, or A, basically we sometimes use A for like the total amount. So A is equal to, well, your interest, right? How much you've earned in interest, plus your principal, how much you initially invested. In our example, this was the $102, and this was the $100 that we initially put into the bank. So, remember, we had a formula for interest. It was P times R times T. So if you can figure out what your interest is, or how much money you've earned in interest over time, and you add that to what you initially had in the account, you will be able to figure out how much money you have in total. This is the formula. This is the main formula we'll use for finding out the total amount, and this is the main formula we will use for finding the total interest amount. Hopefully these two formulas are making sense to you. If you need more examples, I would always say, try plugging some numbers in. Pretend like you're at a bank and you start investing different amounts of money into a savings account with different interest rates. And try a couple years to see and practice over some time period how your money is growing, okay? Now let's get into some practice problems. This first one will really help us see, again, what's going on over time. So you invest $100 into a bank account, all right? Again, we're investing $100. The account pays you 10% of your total investment as interest. So we invested $100, and the bank gives you 10% of that every year. What would happen if you left your money in the bank for 3 years? Okay? What are we trying to find here? What do we need to find in this problem? Well, we need to find the amount of money in the bank after 3 years. So I'm going to write find amount of money in the account after 3 years. So our formula was to find your total amount. You need to figure out how much interest you've earned over 3 years. Oops. And you're going to add that to how much you initially invested, your principal. Okay? So we can do this with a table, if that makes sense first. So you go into the bank and you put in $100. So this is your initial amount, your principal, okay? So right away at the start, I'm going to call that year 0. Year, and then this will be the total amount of money. We initially put in $100, okay? Now, after 1 year, so let's say you put money in January. By December, it's been 1 year. The bank will say, take your $100 and we're going to give you 10% of what you initially put in. Well, how much money is that? How much would you say? 10% of what we initially put in. Well, if it's $100 and we put in and we get 10% of that, that's just $10. So we're going to get $10 every single year. So instead of percent, let's put here $10. So how much money is that? Well, that should be $110. That's how much would be in our account if we took a look at it. After the second year, we have the $110, and then the bank says, hey, you still have money in the account, we'll give you the $10 that we owe you again. So now you have $120. After the third year has completed, you still have the $120 in the bank, but now they've given you an additional $10. They're saying, hey, you still got money in the bank. We're still going to give you the $10 we agreed to all those years ago. So you now have $130. This is the way that simple interest is working. Let's see if we can replicate that with our formula. So the formula says, figure out how much money you've earned in interest over the 3 years, and then add it to the $100 you initially had. So if we expanded this formula, we said it's to find the interest over time, you take PRT, and then again, just add P to that. So the principal was 100, the rate is 10%, and then the time is 3 years. And we're going to add whatever that is to $100. So we've earned 10% of $100. That's $10 for 3 years. So that's $30. That's what this part's saying. We have earned $30 in interest over the course of 3 years. So in total, we have $130. So it works out. Our formula works. It matches what we got for our table. Hopefully this is making sense to you and you're feeling comfortable understanding the difference between how much interest did you earn and what is your total bank account at. Now, what if instead we had invested $200 to begin with? How does that change this? So instead of $100 as our principal, it's now $200. So how much money are we earning in interest? Now the bank says we're giving you 10% of $200. So let's see, 10% of 200, that is $20. The bank says since you put more money in, we're going to give you more money. We're going to give you $20 for every year that you have money in the account. Okay? So over the course of 3 years, you can think how much you've earned. So here, let's say, instead of $100 here, it's now $200. So 10% of 200 is $20, and $20 over the course of 3 years, $20 each year for 3 years, that should be $60. So we'd end up with $160 in our bank account over the course of 3 years. So what we're seeing here is if you put more money in to begin with, you'll earn more in interest, okay? Now that's the idea with simple interest. Let's go ahead and do another example problem, this time trying to identify what's principal, what's rate, and what a total amount would be over time. Quick story time. So I was watching a rerun of the Andy Griffith Show, and I came across a particular episode of Andy Griffith, and I thought, wow, this episode is centered around banking, pretty much, and interest rates. And I thought, what a perfect little application for my class to do. So the Andy Griffith Show, first off, that was a show that ran in the 1960s. I think it was from 1960 to probably about 1966, 67, something like that. And it starred Andy Griffith, who the show is named after. He was the sheriff in this small fictional town called Mayberry. And he lived with his Aunt B, and his son Opie. His son Opie was played by Ron Howard, who is an actor and director. I'm guessing most of you probably know his directing from, I think he did one of the new Star Wars movies, but he's directed a lot more. Anyways, this show featured their life. It was a comedy about things that happened in the town of Mayberry that affected the citizens, and usually something would go wrong, and Andy, the good sheriff, would have to fix the situation. So this particular episode aired back in 1961. And here's the situation. There was a poor farmer that lived in the town. He lived right on the outskirts, right at the entrance of the town. In the town council, the mayor, the treasurer, the town secretary, and the sheriff, Andy, are all meeting to discuss this farmer. You see, he hasn't paid his property tax, his city property taxes, and his house is in disarray. It's, run down, his barn's run down, the land's a mess, it looks terrible, and he has not paid his taxes to the city. So, the city council votes to evict him. They're going to kick him out of his house. And Andy feels terrible. Andy's a very good guy. He's the good sheriff. He's kind of the moral voice of the town and the ethical voice of the town. He feels bad, and he tries to work something out with them, but they say, nope, you have to go and evict him. So Andy feels bad, so he goes over to the farmer's house, and he tries to help him out. He lets the farmer stay with him and his family, and he says, look, until we get you on your feet, you can stay with us, but we got to figure out some way of you to get money. So Andy and his family are meeting with the farmer, and they're going through his stuff. They're trying to help him see, can you sell anything to get money? Is there anything that you could do to earn money? So they're saying, do you have any possessions, any valuables you could sell to just get some cash? And they start going through the guy's possessions, and he just has junk. He's got, old pins and little random things he's collected, nothing of actual value. But as they searched through their things, they discovered an old savings bond. Now, a savings bond is something, you probably all have them. You probably got them as gifts when you were probably very young. A savings bond is something that's worked out through the government. Imagine, so I'm going to go into the bank and I'm going to buy a savings bond. And I put in $100. So this bond, this note, is worth $100. However, it's going to earn interest over time. So I could take this savings bond and I could walk into the bank and cash it for $100. But the bank says if you leave this for 30 years, or 15 years, or there's usually a time period. It's called the maturity period for a bond. If you leave the savings bond, like if you don't touch it, if you just save it for some time period, 15 years, 30 years, whatever, it will earn interest, and we will give you the initial amount plus all of that interest at that time. And usually they're a larger percentage, okay? So it encourages people to buy these bonds. And these bonds, they're given to the bank, they're sometimes given to the government, whatever. But that's the idea of a savings bond, okay? I buy a piece of paper that's worth $100, or worth however much I put into it. And, the agreement is, okay, you've given us this money, and we will redeem this amount of money, but if you wait this extended period of time, like 10, 20, 30 years, it will grow to a much larger amount. So this old man has a savings bond. This bond was purchased for an initial investment of $10,000. And we're going to say that it earned 20% simple interest. It was an interesting scene because Andy is looking at this old piece of paper, and the farmer says, oh, that's my granddad's old savings bond. Or it's an old bond he got from the city of Mayberry. And Andy reads it, and he goes, this bond was initially purchased for $10,000. And it earns 20% simple interest every year? And the guy says, oh, it's probably expired. And Andy's looking at it. He says, there's no expiration date. Meaning you didn't have a certain period of time to cash the bond in. Meaning it can be left over year after year after year, collecting more and more money. Well, this guy's had this bond for years, and he's just forgotten about it. So this bond has been in his family for 100 years. It was purchased back in 1861 from the city of Mayberry. And the writing on it says the bondholder can go into the town treasury office and hand this bond in, and the city of Mayberry will now owe this person how much money? How much money is this old poor farmer now owed by the city of Mayberry? Remember, the city was evicting him in this episode. Now he has a bond that was purchased for $10,000 and has been gaining 20% interest over 100 years. How much money does the city now owe this guy that they were about to kick out? That's your task. Go ahead, pause the video, see what you come up with. All right, hopefully you found out this rather ridiculously large sum of money that this person is owed. So here's some information that we need to start with. Remember, we need to figure out, if we're going to figure out our interest, we need to know what was the principal, how much was initially invested, what was the rate, how much money you were given every year, and what was the time, how long were we earning this money for. So the principal is $10,000, the rate is 20%, and the time is 100 years. So, how much interest was earned? Well, the bond got 20% of $10,000 every single year. So every year, they earned, 20% of $10,000 is $2,000 every single year. And by the way, it's been for 100 years. So $2,000 every year for 100 years is $200,000. This bond has gained in interest $200,000. Is that how much money the city owes this farmer? No. They owe him the interest of $200,000 and they still owe him the initial $10,000 that it's worth. So $210,000 is how much the city of Mayberry needs to pay this old farmer that they were about to evict. If you watch that video of this episode, you'll notice that this wasn't the exact problem that they had. In actuality, if you watch the episode, and I believe it's titled Mayberry Goes Bankrupt, in case you're curious, in that episode, you'll see that the bond itself is actually bought for $100. So the principal in the actual episode is $100. And the rate is 8.5%. The time is still 100 years. It's been 100 years that this bond has been maturing. However, the bond wasn't done by simple interest. Okay? There's other types of interest I've mentioned out there. This bond was compounded interest annually. So it was compounded once a year, meaning they're giving you a percent for the first year, then they figure the next year's amount based on how much is currently in the bank. So you actually get more money that way, as opposed to having a flat rate every single year in simple interest. The more money you keep in the bank, they give you the percentage of that higher amount every single year. So this will probably be a curious extra problem for people. How much money, because I had to refigure this for a simple interest problem. How much money would the farmer have been owed if the bond was actually purchased for $100 at 8.5% interest for 100 years, but this time compounded annually? Try to look up that formula and see if you can figure out the solution for that. Thank you for watching this video. If you have any questions or comments, please let me know. And if you're curious about the actual problem from the Andy Griffith Show, and if you think you have the solution or would like to talk more about it, feel free to let me know. My email for all questions and comments is klinford@wccnet.edu. That's KLINFORD@wccnet.edu. And until next time, take care.